I welcome you to a continuation of our problem-solving situations around Newton's second law. So we will continue with example number 3 in this lesson. A man is pulling a 20-kilogram box using a rope that makes an angle of 30 degrees with the horizontal. Just get the situation, 60 degrees with the horizontal. If he applies a force of 120 and the frictional force is 15 newtons present, calculate the acceleration of the box. So we need to use Newton's second law in this case, because Newton's second law would bring into a relationship the net force acting on the box, the mass of the box, and its acceleration. The first step in solving a problem like this is to identify all the forces acting on the box. So let's look at the forces acting on the box. And we will draw a free body diagram of the situation. We see that there's a frictional force of 15 newtons. And because the box will be moving, I want to label that the kinetic friction is 15 newtons. There is a weight, gravitational force acting on this box. There is a force pulling at an angle of 60 degrees. This is our applied force, and it is 150 newtons. And then we would also have the normal force. The normal force and the vertical component of the applied force will be cancelled by the gravitational force. The motion is along the horizontal plane. So we want to consider only the forces or the components of the forces acting along the horizontal plane. In order for us to do that, we can see there's a frictional force, and the applied force has a component in the x direction. So I'm going to say it's F applied x. Now, we started off by writing F net is ma because the question wants us to calculate the acceleration. Now, we don't have F net, so another way to get F net is to use the old method of adding vectors. We see that the vectors Fk here is acting to the left and Fax is acting to the right. I'm going to choose right as my positive direction. Then this one, left, is our negative direction. In building my equation, I'm going to say F applied x minus the kinetic friction would be equal to the net force, and the net force is A. Now we'll do our substitutions. The mass of this box is 20. I'm going to move over to the next left here. 20 kilograms. Acceleration is the unknown quantity. The FAX needs to be determined. I'm going to use FA cos of 60 degrees in this case, and Fk was given as 15 newtons. So 20A equals 150 cos 60 degrees minus 50. If you do your simple mathematics in this case, just looking for my calculator. You should get the answer. 150 cos 60 for the component of the applied force minus 15. That should give us the product of 20A, and divide 20 into that, get an acceleration of 3 meters per second squared. Because it's a vector quantity, we need to include the direction to the right. With solving Newton's second law problems, the first thing, just a reminder, is to draw a free body diagram. For each of the objects in the situation. The second thing is to use the equation that comes with Newton's second law, F net equals ma. The third thing is then to do your vector addition. And then we must remember that if the number of unknowns will be the same as the number of equations you need to build in order to solve the problem. In this question, we had one unknown, and that was the acceleration of the box. So we needed one equation to solve the problem. Right, let's move on to the next one. I had to delete the drawing in order to have space to work in this situation. Here you have two crates, a 10 kg crate and a 15 kg crate respectively. They are connected with a rope, as I will indicate in the sketch I'll do. A force of 500 newtons is applied to the 15 kilogram crate. The crates move with an acceleration of 2 meters per second squared. 1/3 of the total frictional force is acting on the 10 kilogram crate and 2/3 on the 15 kilogram crate. They want us to calculate the magnitude and the direction of the frictional force present, and they want us to calculate the tension in the rope. So let us sketch the situation here. We've got a horizontal surface. We've got a 10 kilogram crate that is connected via a rope, and we've got a 15 kilogram crate, and a force is applied to the 15 kilogram crate. Fa is 500 newtons. In this rope between the 10 and the 15 kilogram crate, we will have tension. The crate is accelerated to the right in this case, and the acceleration is 2 meters per second squared. Then if we have friction, a third of the friction is acting on this grate here. So this is a third of the kinetic friction. And on the 15 kilogram grate, the friction is 2/3 of the kinetic friction. I think I've indicated everything on the diagram. Now, can you see that there are two unknown quantities here? The tension is unknown and the friction is unknown. If there are two unknowns, we need to build two equations. Two unknowns requires two equations. Before we start building our equations, we need to help ourselves to see the situation by drawing free body diagrams. And because there are no vertical motion, I'm going to ignore Fg and the normal force. You wouldn't do this unless they ask you to ignore it. So I'm, just for the sake of space, going to draw the horizontal forces acting on the 10 kg object. On the 10 kg object, we have tension in the string to the right, and we have a third of the friction to the left. On the 15 kilogram object, we have an applied force to the right of 500 newtons, and we have a friction to the left, 2/3 of the friction. And because tension runs in the string, there is also a tension in the string that is the same size as the tension in the string from the 10 kilogram object will experience. So here we have identified the horizontal forces acting on each of the objects. Now we need to build our equations. The first equation for the 10 kilogram, I'm going to start off with F net equals MA. Then I'm going to say MA equals, choose the positive direction. Now I would choose to the right as my positive direction because the motion is to the right. So to the left is my negative direction. So I would say T minus 1/3 of the frictional force. Then do the substitution. What you have, you substitute. So the mass is 10 times the acceleration. The tension, I don't know. Oh, we know the acceleration. Minus 1/3 of Fk. It's an exception. Yeah, we know what the acceleration is. So we can say 10 times 2. So 20 equals T minus 1/3 Fk. Then we move to the equation for the $15-kilogram object. We've already mentioned that F net is MA, so I'm going to start off with saying MA equals, and I'm going to keep to the right as my positive direction and to the left as my negative direction. So it will be the F applied minus the tension minus 2/3 of the friction. The mass is 15, the acceleration is 2, so together those will make 30 equals 500 minus the tension minus 2/3 of the friction. I have two equations. The one for the 10-kilogram object is equation 1, and the one for the 15-kilogram object is equation 2. In mathematics, you could eliminate one of the unknowns, sometimes by adding the equation, sometimes by substituting the one equation into the other one. It seems like I can solve this problem if I go and I say 1 plus 2. 1 plus 2, so the 20 and the 30 is added together. That makes 50. The 500 is by itself. The t and the minus t will cancel each other out. And then the minus 1/3 Fk and the minus 2/3 Fk will make a minus Fk. Because 1/3 and 2/3 makes 3/3, and that is 1. So Fk is 450 newtons. That is the total friction acting on the object. Of this, the kinetic friction on the 10 kg would be 1/3 of 450, and that would be 90 newtons. No, I'm wrong. I'm wrong. It would be 150 newtons. And the kinetic friction on the 15 kg would be 300 newtons. Good, we've answered A, and that would be to the left. Left and left. Number B asks for the tension in the rope. To calculate the tension in the rope, we could use either equation 1 or equation 2. It seems simpler situation to use equation 1. So I'm going to use equation 1 to answer question B. It says 20 is T minus 1/3 of the Fk. So it is minus 150. Okay, so T is 170 newtons. They ask for the magnitude of tension because for the 10 kg object, the tension is to the right. But for the 15 kg object, the tension is to the right. To the left. That's why they ask for magnitude of the tension only in this question. We've got one to go. In question 5, they say a 2,000 kilogram truck pulls a 500 kilogram trailer at a constant acceleration. The engine of the truck produces a thrust of 10,000 newtons. Ignore the effect of friction. Calculate the acceleration of the truck and calculate tension. I think there is a diagram here that I need to get to. Is that it? 25 degrees. Acceleration is in that direction. Right. Acceleration is unknown. And tension is unknown. Two unknowns, two equations. We start off by drawing a free body diagram for each. Because tension has a vertical component, I think I can't ignore all the components or the vertical forces. So in this case, I'm going to draw a free body diagram that shows all the forces acting on the 500 kg object. So it's tension and the gravitational force. Tension is acting at an angle of 25 degrees. Did they say anything about friction? Yes, they said ignore the effect of friction. Nice. And then there's a normal force here. For the 2,000 kilogram object, 2,000 kilogram, we have tension in the opposite direction, downwards to the left, and it will make an angle of 25 degrees to the horizontal. The weight is downwards, Fg. The normal force is up, Fn, and there is an applied force to the right of 10,000 newtons. Calculate the acceleration. To calculate the acceleration, we need to start off with F net is ma. I know that there are two unknowns, so I'm going to need two equations for the situation. So ma equals, now the component, the object is not moving in the vertical direction, so I'm going to need the component of t here. That would be my x component of the tension. So it's only t cos 25 degrees. So m is 500. A, I don't know. T cos 25. This would be my first equation. The second equation for the 2,000 kilogram object, I'm going to shortcut it. It's 2,000 A would be FA, which is the 10,000, minus TX, which would be T cos 25 degrees. I've got FA's magnitude, so I'm going to substitute it in here. 2000 A equals 10,000 minus T cos 25 degrees, and I've just formed my second equation. In mathematics, I can, in this case, substitute, because T cos 25 there fits in there, I can substitute it with 500A. So that is what I'm going to do in the next step. I'm going to say 2000A equals 10,000 minus 500A. That brings us to 2,500A equal to 10,000. So A would be, is that 4 meters per second squared to the right. So we've calculated the acceleration. Now they want us to calculate the tension. To calculate the tension, I am going to substitute the acceleration into equation 1. I'm going to do that here. So this value for acceleration, I'm going to substitute into equation 1 there. I'm going to write it down here. So 500 times 4 equals T cos 25. So T would be 2000 divided by cos 25. And I get the following answer, 2,206.76 newtons. That brings us to the end of this discussion. Thank you for watching, and I really hope it helps.